I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. You have been using unit circle to find the exact value of trigonometric ratios. Here we'll have an exercise where we give you an option. You can definitely use unit circle to find the values. That is to read them directly, right? So we have 4 different trigonometric functions given here, and we'll see how do we find their value without actually using unit circle. So I'm telling you a very simple method to find these values. So the question here is exact values of the trigonometric ratios given to us. Cos 5 pi by 6, sin 5 pi by 3, tan 13 pi by 4, and sine minus 5 pi by 4. So to find these values, we have to basically figure out 2 things. One, in which quadrant we are. Then using the cost rule, you can figure out whether the value is going to be positive or negative. Third, knowing the related acute angle, we can use special triangle to find the answer. So let's look into cos of 5 pi by 6. Cos of 5 pi by 6 really mean that the pi is divided into 6 portions, so you are in quadrant 3, right? You are in quadrant 2. Since you are in quadrant 2, the cosine value is going to be negative, so we can write this as equal to negative. You get the idea. Now the related acute angle is pi by 6. You can see that this angle is pi by 6, right? So we can actually write this as also equal to negative of cos pi by 6, which is the related acute angle, right? Now to find this value, let's look into the special triangle, which is, as you know, pi by 3, pi by 6, and pi by 2. So if this is pi by 6 angle, right, the sides are 1 to square root 3, and cos pi by 6 from here you can read directly negative half. Does make sense? So simple, right? Let's follow this procedure once again and now find what is sine 5 pi by 3. Now how do we find sine 5 pi by 3? Follow the same procedure, right? So again, where will this be? 5 pi by 3 is going to be in quadrant 4, right? That is 5 pi by 3. So the related acute angle in this particular case is pi by 3, as you can see, right? So we could write this as negative because using the cost rule, we know sine is negative here, and the related acute angle is pi by 3. So once again, I am using the same triangle which I have drawn earlier. That is pi by 3, right? And the sine value is opposite over hypotenuse. So it could be written as minus square root 3 by 2. Makes sense, right? So we utilized the special triangle pi by 3, pi by 6, pi by 2 to find these answers and the cost rule. Let's look into tan 13 pi by 4. So can you tell me in which quadrant will the principal arm be when we are trying to figure out the value of tan 13 pi by 4? Well, 13 pi by 4 means you go one full circle, that is 8, right? Pi by 4, and then 4 pi by 12, and then 113. So you are actually in quadrant 3. In quadrant 3, tan is positive, therefore this will be positive, and the related acute angle is pi by 4. So you can use the special triangle, which is pi by 4, pi by 4, pi by 2, right? And clearly the value is 1, and therefore this ratio is 1. Is that clear to you? Perfect. Now let's look into the last one where I'm taking the angle as minus 5 pi by 4. Minus means the angle will be clockwise, right? So minus 5 pi by 4 really means that it is going to be right there, right? So you are in quadrant 2. In quadrant 2, sine is positive, right? So we can always write this as sine pi by 4. Using this particular triangle, we know the value is 1 over square root 2. So we can write this as 1 over square root 2, positive value. It should be rationalized, so after rationalization, we are writing square root 2 over 2. Makes sense? So that is how we are going to find the exact values of these trigonometric ratios when we are given measurements in radians. Perfect? I hope that makes sense. In case you want to learn from me, you can always send an email on the address given. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.